All right, so now we've got a framework to work in, and we're going to start building our CPU. So we're going to essentially walk through the pieces of the CPU and implement each piece the same way I walked through it from left to right. So we're going to do the next PC logic, instruction fetch from the instruction memory, decode, register file read, arithmetic logic unit, register file write, and then we'll add the branch target computation for branch instructions. So as you add each piece, you can check each piece in simulation, make sure that its outputs generally are correct. And so we're going to start with next PC logic.
And we're going to do that assuming that we're executing the instructions sequentially. So we'll worry about the branch instructions that are changing the PC by an offset later. First, we'll get the PC behavior so that the PC is incrementing, right? And you've coded up an incrementer now a couple times. So the same old familiar pattern. So here we're assigning the PC for an instruction, for this instruction going through the pipeline, to be the PC value from the previous instruction plus 1. Or really, this is a byte addressed PC, and the instructions are 32 bits, so we're incrementing the PC by 4. Labeled here as plus 1 instruction, but plus 4 in absolute terms. So PC is going to be the incremented PC value from the previous instruction. Right, so again, that implies a ahead by 1 reference. One little wrinkle with this next PC logic, we have to make sure that we're starting off with the right instruction. And we're going to code this up so that the first instruction that we execute is going to be the instruction at PC 0. So we have to make sure that the first cycle out of reset is resulting in a PC value of 0. If we just code this up to say on reset, the PC is 0. After reset, the PC is the old PC plus 1. That means on the first non-reset cycle, we're actually going to get 0 plus 1 is 1. So that would mean the first instruction that we're executing would be instruction 1, not instruction 0. And the implication there, there are a couple different ways you could code up the logic to make sure that you're starting with the value of 0. Probably the simplest way is to, instead of resetting on reset itself, you reset on, reset to 0 based on the reset of the previous instruction, right? So that means if the previous instruction was a reset instruction, then this instruction should use 0. Right, so that will then now include the first valid instruction in the pipeline, the first non-reset instruction. So again, we want to reset to 0 based on the previous instruction's reset, and that will reset to 0 for the first instruction, first non-reset instruction of execution. All right, so instead of using just reset in your mux expression, that's choosing the 0 input, which I haven't drawn in the slide. Use previous reset to select the 0 for the PC. All right, so again, code that up, check that in simulation, look in the waveform, confirm that you're saving as always, and make sure the PC is starting off with 0 for the first non-reset instruction.